A cosmic odyssey, 10 quintillion years into the future. Strap into your time machine and brace yourself for a journey beyond imagination. We're not just stepping forward a few years or centuries, we're hurtling 10 quintillion years into the future, a time so distant it defies comprehension. Picture 1 followed by 19 zeros, a number so vast it could swallow your mind whole. This is 10 billion years, a cosmic saga where stars fade, galaxies collide, and the universe itself whispers its final secrets. What happens to Earth? To humanity? To the very fabric of reality? Let's dive into the abyss and find out. Your time machine hums to life, and you land a billion years from now. The Earth you know, lush with forests, oceans teeming with life, a radiant blue marble is a memory. In its place lies a cracked, desolate rock baking under a merciless sun. Over the eons, our star has grown hotter, its temperature rising 1% every 100 million years. Now, Earth's surface sizzles at 125 degrees Fahrenheit 52 degrees Celsius, a barren wasteland where no life can survive. The carbon cycle collapsed long ago, plants withered, animals perished, and the oceans boiled away into a ghostly mist. What about humanity? If we're lucky, we've escaped this dying world, scattering across the stars like cosmic seeds. Picture vast colonies on distant planets, perhaps orbiting gas giants in the outer solar system, or artificial habitats floating in the void. But Mars? It's no refuge either. The sun's heat has turned it into another scorched relic. To survive, we'd need to venture far beyond, perhaps to the icy moons of Jupiter or Saturn, or even to other galaxies. But there's a wilder possibility. What if we've shed our biological forms? Imagine a future where humans upload their consciousness into quantum computers, living as digital entities in a virtual cosmos. These digital souls would need energy, massive, sustainable energy to keep their servers humming. Companies like Hillcrest Energy Technologies are already paving the way with innovations like their zero-voltage switching ZVS inverter, boasting a staggering 99.8% efficiency. This tech converts solar power with minimal loss, potentially powering interstellar colonies or electric vehicles that race across alien worlds. It could shrink EV battery packs by 20%, slashing costs and boosting performance for everything from Formula E cars to future starships. Curious? Check out their work in the description below. It's the kind of tech that could keep humanity's spark alive in this unforgiving future. Fast forward to 10 billion years. Your time machine glides through a solar system that feels like a stranger. The sun, once a blazing beacon, is now a white dwarf, a dim, Earth-sized cinder glowing faintly in the dark. After burning through its hydrogen, it swelled into a red giant, likely engulfing Mercury and Venus and reducing Earth to a molten iron core. Its outer layers drifted away, leaving this ghostly remnant to cool for billions of years. But the real spectacle is unfolding on a galactic scale. The Milky Way and Andromeda, our closest cosmic neighbor, are locked in a gravitational dance. Over millions of years, their stars swirl together like glitter in a cosmic snow globe, forming a new galaxy, Andromeda. Don't worry about stars colliding. The vast distances between them make that unlikely. But the chaos could fling our solar system 3 times farther from the galactic core, or even eject it entirely into the void. Where are the humans? If we've survived, we're no longer tethered to this dying solar system. Picture floating cities orbiting neutron stars, or vast networks of habitats spanning entire star clusters. Perhaps we've mastered faster than light travel, colonizing galaxies far beyond Andromeda. Or maybe we've gone fully digital, our consciousness woven into a cosmic web of artificial intelligence. But all these dreams hinge on one thing: energy. Without breakthroughs like Hillcrest's ZVS technology, which could power everything from interstellar fleets to virtual realities, humanity's future hangs in the balance. Want to see how they're shaping tomorrow? Hit the link in the description. Your time machine surges forward to 100 trillion years and the universe feels eerily quiet. The stelliferous era, the age of star formation, is over. Red dwarfs, the longest-lived stars, have burned out after 80 to 100 billion years. Massive stars exploded as supernovas, leaving neutron stars or black holes. Brown dwarfs, those failed stars, cool to a faint, barely perceptible glow. The raw materials for new stars' clouds of hydrogen gas are nearly depleted, locked away in the remnants of dead stars. What does this mean for humanity? If we're still here, we've likely transcended physical form. Imagine us as pure energy, our minds housed in quantum matrices powered by the last flickers of dying stars. Or perhaps we've built artificial habitats around neutron stars, harvesting their rotational energy to sustain our existence. Another possibility. We've created pocket universes in labs, bending the laws of physics to craft new homes. But these feats require energy solutions far beyond what we have today. Innovations like Hillcrests, which boost renewable energy efficiency and cut costs for advanced systems, are the first steps toward that future. As you drift through this darkening cosmos, you notice rare flickers of life. Collisions between brown dwarfs might spark new stars, burning for trillions of years. White dwarf mergers could ignite supernovas, briefly lighting up the void. But these are fleeting moments in a universe sliding toward darkness. Welcome to 10 quintillion years, the degenerate era. The universe is a graveyard littered with the corpses of stars, white dwarfs, neutron stars, and black holes. Star formation has ceased, and the cosmos is a cold, dim expanse. Matter itself is decaying as protons disintegrate over trillions of years, a process so slow it's almost imperceptible. The universe feels like an abandoned stage, its once vibrant players long gone. If humanity persists, we're no longer recognizable. Perhaps we exist as digital consciousnesses, sustained by energy harvested from dying stars or black holes. Picture vast networks of AI-powered habitats orbiting the remnants of neutron stars, or even tapping into the mysterious dark energy that drives the universe's expansion. But even these remnants won't last forever. The universe is cooling, dimming, and slipping toward an inevitable end. What's next? Could we manipulate reality itself, creating new universes to escape this dying one? The science of today hints at such possibilities: quantum tunneling, multiverse theories, but we're only 200 years past the Industrial Revolution. Imagine what we could achieve in billions of years. The key? Energy. Without it, even the grandest visions crumble. Check out the link below to see how companies like Hillcrest are building the foundation for humanity's cosmic future. Your time machine lurches to 10 duodecillion years, a 1 followed by 40 zeros. The universe is now the domain of black holes, cosmic titans that devour everything, even light. Stars, planets, and galaxies are distant memories. But black holes aren't eternal. Through Hawking radiation, they slowly leak mass as particle pairs form at their edges, one falling in, the other escaping. Over unimaginable time scales, even the mightiest black holes evaporate, leaving only a faint glow. If humanity still exists, we've transcended physical form entirely. Perhaps we live in synthetic realities, our consciousness powered by the last scraps of energy from dying black holes. Or maybe we've mastered the art of universe creation, crafting new cosmos in laboratories beyond imagination. But the universe around us is bleak, a cold, dark void where matter itself is unraveling. At a Google years, a 1 followed by 100 zeros, you arrive in the dark era. The last black hole has evaporated, leaving a universe of scattered subatomic particles. Dark energy, the force driving cosmic expansion, has stretched space to its limits. The temperature hovers just above absolute zero, a big freeze that cloaks the cosmos in silence. You zip through this desolate expanse in your time machine, searching for anything, a single particle, a fleeting spark, but the universe is empty, cold, and still. Is this the end? Not necessarily. Some theories propose a big crunch, where the universe collapses back on itself, potentially sparking a new Big Bang. Could this cycle repeat forever, with our universe just one chapter in an infinite story? Or is the Big Freeze our final fate? Scientists lean toward the latter, but the mystery endures, teasing us with possibilities. As the universe fades, humanity's survival depends on audacity. If we reach a Type 7 civilization, we might wield the power to create new universes, bending reality to our will. Picture a lab where scientists or whatever we've become ignite a new Big Bang, crafting a cosmos tailored for life. 2 centuries after the Industrial Revolution, we're already dreaming of such feats. In billions of years, who knows what we'll achieve? But it all comes back to energy. Without sustainable, efficient solutions, our dreams of cosmic dominion remain just that, dreams. Companies like Hillcrest Energy Technologies are already tackling this challenge with tech that could power the starships, habitats, and virtual realities of tomorrow. Their ZVS inverter, for instance, could revolutionize everything from electric vehicles to interstellar colonies, cutting costs and boosting efficiency. Want to dive deeper? Check out the link in the description. Did this journey through the cosmos blow your mind? If you're as fascinated by the future as we are, smash that like button and share this video with your fellow space explorers. Subscribe to BrightBoundX for more epic adventures into the mysteries of the universe, and hit the link below to explore the tech powering humanity's next chapter. Let's keep pushing the boundaries of what's possible together.